Okay, so next we're going to be looking at limits and averages. So basically just two different ways of working with ranges of numbers, right? So let's start with limits. So you'll probably be familiar with these terms, min, max, and clamp. You'll see them. There's VOP nodes, there's vex functions, there's HScript functions. It's pretty sort of self-explanatory. But there is something sort of counterintuitive about the way, particularly that minimum and maximum are used, and sort of how they practically can be used in our art. So let's take a look at one of these at a time. So I've got a number line here, and the green number is my input number. So I'm going to be able to sort of slide this backwards and forwards and show you whatever I put in at the top will come out over here. Then blue is my limit. So within the minimum function, you will normally feed it two numbers. Okay, yes, you can actually feed it multiple numbers, and we'll talk about that just now. But for the sake of understanding what it's doing, we're just going to examine two different numbers that it's being fed, okay, instead of a whole array of numbers. So blue is the second number in that input, right? Which will often be used as you're manually feeding in that number. And the green number would be something that you are maybe reading from. So reading from your geometry or whatever. Okay, so, and then the result of this function is the purple. So now that we know how this is working, what a minimum function is doing is it is selecting the minimum value that it is given. So in other words, it chooses the smallest of the two numbers, or if you give it even more than two numbers, give it 3, 4, you can give it a whole array as well, and it'll search within the array. So whatever data you feed it, essentially it's going to find the smallest number, and it's just going to return that number. Okay. So at the moment, 2.2, which is my input number, is smaller than 3.21. And so the result of the minimum function is 2.2. Okay, so that's pretty simple. And then if I take my input number higher, you'll see that it now selects the blue number because obviously that is smaller than 4.6. Okay, so this is how minimum works. But what's counterintuitive about it is that you can use the minimum function to set a maximum. Okay. So watch what happens when I move this green line, right, backwards and forwards. I'm using the minimum function, and I'm essentially setting this number, well, let's make it a rounder number so it's easier to understand. Okay, so 4 is the maximum that I want this value to be. So if I move my input number backwards and forwards, right, so let's say this green is the speed of a particle. Okay, so it starts really slow and it starts accelerating. And as it wants to accelerate faster to about 7.64, meters per second or whatever, you see here that the minimum function is clamping it to a maximum of 4. Okay, so I know it gets confusing where minimum is setting a maximum, but it's because of the way that the function works. The function is choosing the smallest of these two. And so as soon as your input number goes higher than the other end, essentially your limit that you're setting this limit is going to always be smaller than this amount. So it will choose that limit and will never choose the higher number. Only when our number comes below the limit, then it prefers to select that number instead. Okay. So in this way, we can actually use minimum to set a maximum speed or a maximum maybe height of some particles. So you could check their y value and then say, okay, I want you to have a y value that is the minimum between your current y value and 4. And what that'll mean is that the particles will never rise above a height of 4. As soon as they hit that limit, they will just stop at that height. So they'll be able to move along x and z, but they will not go higher than y. And so essentially minimum is used to set a ceiling or a maximum value. Okay, well, a maximum limit using the minimum function. And then conversely, the maximum function does the opposite, okay? So the maximum takes a look at all the inputs we give it. In this case, we're only giving it 2, but we could give it multiple if we wanted. And it will choose the maximum of the 2. So in other words, which of these 2 is a larger number? So in this case, it says 6.12 is larger than 4, so that's what I'm going to choose. So this then works the opposite way, where the maximum function is setting a minimum because it's always going to choose the highest value. And so when our input number goes below our limit, well, it's going to just choose the limit value instead. And only when our value is higher than the limit, then it will select our input value. So you see here, our purple line never gets smaller than 4, but it can get larger than 4. So we use maximum to set a target minimum. Okay, and same thing, we could set this for, let's say, speed of particles. So, if they start to slow down, we insist that, nope, you can never go slower than this certain velocity. Okay, so very useful. And then clamp is essentially both, right? With clamp, we're setting 2 input numbers. Okay, now clamp is a little different to these, even though in practice, it's often used in a very similar way, but minimum and maximum do have alternate modes where they allow you to feed it a wide range of numbers. So you can actually feed 10 different numbers into a maximum function, and it will just return the highest number of those 10. Whereas with a clamp function, you can have only one input number, and then you need to give it 2 numbers. A minimum and a maximum, okay? And then it will essentially clamp this input to within that range. So when it's used like this, where we're just wanting one number to be limited to a certain amount, either minimum or maximum, then it seems to be quite similar. But the minimum and maximum also have the extra feature of being able to go through, let's say, an array and select the highest value, or to maybe have multiple limits. With a clamp, it's just one, okay? But because you can do a minimum and a maximum, it's quite useful in this way, right? So again, here we can set our 2 numbers, although I'm using here the 2 different numbers. So you can set sort of the minimum that it should ever get. So let's say it can go only as low as 1 and as high as 5. So now our input number, our green number, as we move this, our purple matches it until we hit the maximum there, and then also it matches it until we try to go below the minimum. All right, and so that's how clamp works. Clamp is probably the more easiest one to understand. That's quite intuitive, but minimum and maximum are often misunderstood, and that's why I wanted to show it in this context. Okay. All right, so next we're going to take a look at averages. So what I have here to show you the different averages is an array of numbers. Now, if you haven't come across that term yet, an array is just a collection of numbers, okay? It's just a group of numbers or a cluster of numbers. You can think of it that way, right? And you'll often come across this term, and it's quite scary. A lot of people get very confused with arrays and tend to avoid it. Obviously, I cover it in Vex and Python courses a lot more. So if you want to know more about arrays, those are the types of courses you can take, where we then go into how to actually manipulate and work with arrays. But for our cases here, we're just talking about essentially just a bunch of numbers. And these numbers can be literally in the form of an actual array, which is a data type within Houdini, or it could just be a bunch of numbers. Okay, so these could be maybe, or got a bunch of points and they each have a different value. Okay, and so when we're looking at all the values of those points, we're kind of calling it an array, but really Houdini doesn't treat it as an array. It's just going through each point and looking at all the values and then averaging those values. Okay, so this can come in many forms, but I just want you to understand that what we're talking about now is just a few numbers. Okay, I've got just a set of numbers in front of me, and they are in an order. Okay, in a very particular order, and there can be multiple of the same number, right? So let's say these are a bunch of points, okay, and they all have, a value, Okay, this value could be anything. It could maybe be the speed that they're moving or their position along y or whatever it is. Okay, so when we talk about averaging, there's actually 3 different types of averages, right? I mean, there are actually even more, but this is kind of the main 3 that we talk about. And you'll come across these in a few different areas in Houdini. There are vex functions for it, there are VOP nodes for it, HScript functions to do this, as well as even if you maybe do promote, for example, if you promote an attribute from point to primitive or up to detail or whatever you promote it to, it's going to then ask you how do you want to kind of collapse these values. Because if you take all of these values, if these are point values, and then you promote them up to detail level, it can only take one value forward. And so it's asking you is essentially, okay, how do you want me to get to that value? Do you want me to take the minimum, the maximum, the first value and ignore the rest? Or do you want me to average? And you'll find in the attribute promote node that mean, mode, and median are all options, okay? So it's important to understand what these are. And also you'll notice that there is minimum and maximum, which we just spoke about as well. So there are different ways that you can essentially get down to a single value. Averaging is one of them. And these 3 are different types or methods of averaging. Now, when someone talks about an average, they actually are referring to the mean, okay? Generally, this is the sort of default method for averaging. And in fact, in VOP level, you'll find that there is an average node. And the average node has only one mode, which is mean. Okay, so it doesn't let you select the different types of averages. It literally just does the mean average. Okay. So the mean average, what this is doing is it's taking the sum of all of the numbers in that array, so adding them all together, and then dividing by the count. So the count of the number of items, right? So here we have 9 items. We have literally 9 different numbers. It adds them all together, which equals 43. And then it divides by 9 because there are 9 items in the array. And so the average, the mean average, is 4.78 in this particular example. Okay? So this is kind of it's almost literally like the halfway point between all of these numbers, really. It's just the most kind of the most average way of averaging. Okay, the standard default way of doing an average is mean. But then we come to mode. So mode is a little bit different. Here what we do is we count the number of occurrences of a single number. Now, if your value is something very, very disparate, something like a float where it could be, you could have one value that's 2 and then one value that's 2.0001. If they're different by a very small margin, mode is not generally going to be very useful. It's normally used for things like where you have integer values. So like we have here, there's a bunch of 2s and a bunch of 4s, all right? Or even with something like strings. So you have maybe maybe like a piece number, like a name or something like that, or a path or whatever, and you want to see what is the most commonly occurring path in these lists of paths. Every point is pointing to a different location on disk, but you want to see which one comes up more often than the others do. Okay. So what it's essentially doing is gathering them into similar little clusters like this. So in our example here, we have 3 2s. We also have 2 4s, and then the rest of the numbers only occur once each. And so the mode is 2 because this is the most common occurrence in this array. Now you can also have some instances where, so let's say we took the same array, but we just dropped one of the 2s and we did the mode function. So that would be called bimodal. So that means it has 2 modes because there would be 2 2s and 2 4s. Okay, so 2 and 4 are then the mode for this. Now Houdini doesn't really work with bimodal as far as I know, what will happen in an attribute promote if you do a mode function and it is bimodal, I think it arranges it kind of like this as well, where it will take the minimum value of the two bimodal values. Okay, so as far as I know, if we still had the two 2s and two 4s and we ran mode, it would still return just 2 in Houdini, because it's going to just take the 2 because they're smaller, right? But mathematically, it is possible to have something that is bimodal, or I guess even trimodal. But yeah, so mode, you got to be careful exactly how you use it, because sometimes, it doesn't, like if you use it with floats, it's really just not going to be useful, because all your values are going to be different. Even if they're almost similar, they're going to be very slightly different. And so mode is just going to return nothing, basically. Okay, but in certain circumstances, it's very useful. And then median. So what the median does is it arranges the array, so the numbers that it's examining, and it arranges them in order, okay? So alphanumeric order, and then it takes the center value. So in this case, we have 9 values, so it puts it in order, and the center value, so here on either side there are 4 values, so you can see this is the center. It takes this value. Now, you'll see, let's take the difference between here. The mean is kind of the more accurate middle of all of these values, right? So the average. The median, though, you see this comes out as 2. What median tends to do is it kind of avoids or ignores spikes in your array. So you'll see here we've got a lot of numbers, and most of them are around about the kind of 0 to 5 range. You see, like we've got a 0, a 1, we've got a lot of 2s, we've got a bunch of 4s and a 5, and then we've got the sudden spike of a 23 in there. So that 23 is having quite a large influence on the mean. It's pushing that number up quite high. So the average is now 4.78. which is still within the kind of range of, like I said, between 0 and 5, which is kind of what we have, but it's on the upper end. And I mean, there is only 1 5 and there's 2 4s, but then there's a bunch of 2s and a 1 and a 0, but it's still being pulled quite up towards that 5 because we have the 23 in there. If I took the 23 out, the mean would drop significantly, whereas the median tends to avoid that, because you see, it doesn't really care that there's this giant spike. It's just looking at, if I arrange all of those numbers and then look right in the middle, I'm going to kind of get a sense of what's happening with these. It would also be the same as if we had like maybe very negative numbers, negative 100. I could add in here and the median would still be 2. Okay, so that can give you some weird results. Sometimes that's not actually what you want, because you want that 23 to be taken into account. But, you know, it's up to you. This is why you need to understand what the different averages are doing so that you can select which one works for you the most. Now, I just want to show you another example with a very similar array, but we've just made a very slight tweak to it just so that you can see how these numbers change. So all I've done, taken the exact same array and dropped the last number. And in fact, the last number is a 0. So this is kind of interesting to see how much just one number makes a difference in all of your averages by dropping just a 0. Okay, we haven't even dropped the 23, and yet we'll see how large of a difference this makes. So for the mean, for example, it's exactly the same. We just add it all up. The result is still 43, but we divide by 8 instead of 9. Okay, it's still 43 because we were adding 0, so that really didn't make a difference to the sum, but it makes a difference to the number that we divide it by. And so we're dividing it by 8 instead of 9, and so our mean creeps up even more. Because we've dropped a low number, our mean creeps up more because it's weighted more towards the 23. The mode is completely unaffected. Okay, because it's looking at the most common occurrence, and what we dropped was something that was not a common occurrence. So the mode really would not care if we dropped anything else other than the 2's. Okay. The median, now this is interesting here. What happens with median when you do not have a center? So in other words, when you have an even number of items that you're assessing, then there is no middle. So then the middle is 2 numbers, and what it does is it takes the mean average of those 2. So it does the same thing that mean would do, except on a much smaller scale, because obviously it's only looking at 2 numbers, so it adds them together and divides by 2. So here in this case, we've got 2 and 4, adds them together to 6. 6 divided by 2 is 3. Okay, and so our median average is 3 in this case. By dropping the 0, our median average went up, and our mean average went up, and our mode stayed exactly the same. Okay, so this is just a way so that you can understand what these different averages are doing, because you will use them to great effect. Most of the time, you're probably going to rely on mean, but occasionally you'll use median, depending on if you want to maybe drop those kind of spikes out of your array. And then mode is mostly going to be used for things like integer values or strings when you're trying to examine that. So that will be more for maybe more if you're working with like Python or Vex to do like string manipulation. Okay, right. So that's our lesson on sort of limits and averages, and so we'll now move on.